Okay, these videos will be pretty brief because I'm just going to show you what I've already done. Convert each pair of polar coordinates to rectangular. So if this is polar r theta, we want to convert it to, I'll change it, x and y. Well, x is the radius times cosine theta. So that's when you look at the unit circle at 60 degrees. Cosine is 1/2. Sine is √3/2. So radius times cosine 60, so radius times 1/2, half of 4 is 2. And then for sine, 4 times the sine of 60, so 4 times √3/2, 2√3. That's it, using the unit circle. And so it's the same thing when they're radians. You find the 5π6, cosine is -√3/2, sine is 1/2, radius, so radius times cosine 5π6, so when you multiply you get -2√3, and then y is 4 times sine of 5π6, which is 1/2, which is 2. And then this is the work that I would want to see. The radius theta then converts to the xy on both of those. Now when you convert back, convert each pair of rectangular, so xy, to r theta. All right, well, r is the x squared plus y squared. Okay, so let me explain why that is. So if this is 1 and we're up there at √3, we went this distance, so it still is 1 subtract 0 squared. It's just that whole distance is 1, and that whole distance is the distance of square root 3. So that's why that is. So square root of x squared plus y squared, and then you simplify that. So I did that down here, which is the square root of, because √3 squared is 3, 1 squared is 1. Add those together, you get 4. Square root of 4 is 2. And then to find this angle right here, it's opposite the tangent, right? So tangent theta is opposite over adjacent, and then you just take inverse tangent both sides. So the setup is always going to be theta is equal to inverse tangent of y over x. And then here we have our xy, here we have our r theta. And then that's just another example. But look at it's the same values, but in the third quadrant. Notice, well, I labeled which quadrant they're in. And, whoops. And the reason that could help is, remember, there are two versions. When you do, when it becomes inverse tangent of √3, well, that's going to be in the first and the third. So you have to look at the xy value to decide which quadrant, which theta you're going to be talking about. Because for this, it could have been π3 or 4π3, but because both of these were negative, it had to be 4π3. All right, that's it for converting rectangular to polar and from polar to rectangular.